Hi, this is a continuation of our last machine learning Quantlab session that we did. And with this, I'm going to go through an example with time series that we didn't have in the last example. I'm not going to go through the code at all. I'm just going to show you the example using time series in Quantlab with machine learning. So what do we have that we didn't have last time? Well, here we try to predict the future of the euro-SEK exchange rate. And in order to predict that, we use the time series of the euro-SEK itself. And we also use the interest rate, the 1 year euro swap, and the other cross rates, the USD SEK, the euro US dollar, and also the OMXS 30 equity index. So and what we have is that we have a rolling 6 days window for all these time series, and we try to predict the next day's level in the euro-SEK exchange rate. So we're learning from the time series and trying to predict the euro-SEK. And in this example, we're running 100 loops using time series from yesterday's closing to 2010 backwards, and we're running that 100 times. And you can see the learning here. This is the error, and we're running 95% of the history we're using as the learning, and the last 5% of this time series we're using as out of sample to check. So this is the in sample and this is the out of sample check. So we can see that we're getting some sort of linearity here along with the red line, which would be the true predicted result for the euro-SEK. So let us assume that we have trained the network using 100 loops in random order with normalized data, and we're using the tanh transfer function with a topology of 5 hidden neurons. With this network trained and assuming that the out of sample would be affirming our notion that this is being a correct trained example. Okay, so with the trained network, we can now get on with predicting something. So let's then enter some data that we feed into the network. And what we're using obviously the same data with the 6-day rolling history from the same time series. We're then feeding this also with the last point in real time that we're taking from, in this case, we're using the Reuters real time. To get the prognosis using the trained network, obviously we need the 6 days history. So here we have the euro-SEK exchange rate itself, and we have the interest rate, the euro swap, 1 year, and so on. And here we have the OMX. And this column, the diff column, I've entered so we can stress any of these values. This would then be the result of the trained net. So with this data in, this would then be the 1 day prognosis for the euro-SEK exchange rate according to our trained net. So compared to right now in real time, the exchange rate is 974, and the prognosis is 976.77. So it has a higher prognosis. So now we can check the sensitivities. So let's play around with what we would assume being the most sensitive, which is the current rate. And if we add an extra whole figure to this exchange rate, we see obviously the prognosis goes up. So, and this is obviously expected because the most of the weight should be on this historically. What we can also see is somewhat unexpected is that is not linear. So if we take the interest rate, add a percentage point, the prognosis goes down, and as we continue to add interest rate percentage points, it goes down, but only so far. So we reach a limit where it's not becoming sensitive anymore, or at least it's non-linear. So we can make a very big number on this interest rate, and then the exchange rate doesn't move beyond that. And again, this is a non-trivial example because we have a non-linear neural network model. So it's not reacting in a linear fashion. And we can also see that if we move the interest rate 2 days in a row, will not be the same as moving it only 1 day. So there's clearly some sort of history sensitivity going on here, or the difference between 2 days history. So all these data are active, even though some are. If we move the OMX index 5 days ago, it doesn't move around a lot. If we move the real time, we get a prognosis of a EUR/SEK that goes down. But if the day before that was also up, that it's not sensitive to this. So the neural net has clearly found weights that are nonlinear and non-trivial in terms of how sensitive these data are for our prognosis. And this is our session. How to using the time series, we're training a net. We're looking at some outer sample, seeing that we enjoy the fit, and then trying to get a prognosis out of this. Right or wrong, this is what it does. Thank you very much.